It's relatively common in Python to have functions that can receive an arbitrary number of arguments. In fact, we've already used a couple of those functions in Python. For example, we used the min function to be able to do things like this, where we could pass any number of arguments we want and it will figure out the minimum of those arguments. Now, the way that you define such a function in Python is by using an asterisk on a parameter name. So let's show you what we're talking about here. So let's say we want to define an average function that's capable of taking the average of any number of numeric values that you pass into the function. You can write a parameter of this form where the word args is just a convention, not a requirement. And let me go ahead and write out the rest of the function, and then we'll talk about this. So we want to return the sum of the arguments, and we want to divide that by the length of that parameter, which is going to be the number of total arguments. So what happens when you apply the asterisk to a parameter name is this tells the Python interpreter, when somebody calls this function, pack up all of the arguments into a tuple and pass that tuple into the function definition. So args is actually going to be a tuple of whatever arguments are passed to this function. Now, we've seen previously that when you pass a sequence to the sum function, it can calculate the sum of all the numbers in that sequence. And we've seen that when you pass a sequence to the len function, it can tell you how many elements are in that sequence. So let's go ahead and define that function, and now we can go and calculate the average of a couple of values. So let's say we give it 5 and 10, and it gives me back the average of 7.5. Let's recall that and add in another value, and of course the average of these three values happens to be 10. And let's recall it and add in another value just to show you that once again we can calculate the average of those values. Now, I'm not doing any error checking up here, so it is possible I could get an error with this as well. For example, if I call average with no arguments, then it's going to result in a zero division error because of the fact that I didn't check for divide by zero. If the length of the tuple is 0, there are no elements, and therefore I wind up with the error that you see down below here. Now, if you want to use this capability, you can do that in any function, including functions with arguments, with required arguments or arguments that have default values. But no matter what, this particular argument must be the last one in the parameter list. Now, one interesting thing about Python is an operator that enables you to take a sequence of values and unpack that sequence so that the values can be passed into a function. So, for example, the average function that we defined up above here is capable of receiving a whole bunch of arguments that perhaps are stored in a list already. So, as we demonstrated in some earlier examples, if you want to calculate a class average, you are going to total up some grades and then divide by the number of students. Well, let's assume that we already have a list of grades. Let's call it grades. And let's go ahead and put some values in there. So let's do 88 and 75 and 96 and 55 and 83. So of course we've already seen that we can do things like call the sum function with grades as an argument and calculate the sum of these values. We've also seen that we can use the len function to figure out the number of values in this list, and of course we could use that to calculate the average, but we already have that defined up here in our average function. So what we can do instead is call the average function, and we can say unpack the elements of the list called grades and pass those into the average function. So this is the equivalent of literally passing in this highlighted comma separated list of values as the set of arguments to the average function, and indeed it gives me back the class average in that case.